Hello everyone, today I am going to discuss one of the most frequently asked questions in instruction and out instruction. So let's get started with in instruction. It is used to read data from the input devices such as keyboards, switches, etc. This is the format of instruction. In followed by 8-bit port address. It is a 2-byte instruction because in instruction involves immediate addressing mode. We need 3 machine cycles to execute in instruction, not only in instruction. Any instruction that deals with immediate addressing mode needs 3 machine cycles. The first machine cycle is used for opcode fetch. The second machine cycle is used for reading the port address. The third machine cycle is used for execution or reading the data from the input device. Now the first machine cycle uses 4 t-states always. The second machine cycle uses 3 t-states and the third machine cycle uses 3 t-states. So therefore overall we require 10 t-states and 3 machine cycles for executing in instruction. In order to give you a clarity, let me consider an example. In instruction with the port address 84. Suppose that we are writing our code at 2065. Then the first machine cycle starts with the 2065 which reads db hex which is the hex code for the in instruction. At the end of the first machine cycle, the processor understands that yes, this is the in instruction, and now in the next machine cycle I am going to get the port address. So it then moves to the next machine cycle, that is 2066, where 8084, that is the port address, is given. And now at the end of the machine cycle, second machine cycle, it understands that yes, I have got the complete information now. Now I have to move on for execution. So at the beginning of the third machine cycle, it moves to the 84 port address, where the data from the input device is transferred into the accumulator. So this is about in instruction. Now let's have a look at the timing diagram. Now before going into timing diagram, I would like to make a point. The program counter or the program control can move to the new address only when ALE goes high. ALE goes high only during the first T-state of every machine cycle. So in this case, during the first machine cycle, the ALE goes high, and then it moves to the 2065, where the opcode DB is read. And then it waits until the ALE goes high again, which is done in the second machine cycle. Now it moves to the 2066, that is the second instruction which we have seen, where 84, that is the port address, is given. And now at the end of the machine cycle 2, it understands that yes, I have completed taking the instruction. Now I have to move on for execution. So at the beginning of the third machine cycle, it moves to the port address 84, and then it reads the data from the input port. So this is it about in instruction. We have 4 important signals. Those are IO memory bar, read bar, memory read bar, and IO read bar. What is IO memory bar? IO memory bar, this signal goes high when we are referring to input output device, and this signal goes low whenever we are referring to the memory. And then read bar goes low whenever the read operation is being done. That is, in this case, if you consider the read operation is done in this case, and then it moves on at this position, and then it moves on to the second machine state where the read operation is done in this specific position, and then in the third machine cycle, at this particular address, the read operation is being taken place here. So in this exact positions, the read bar goes low, if you can see. And then memory read bar goes low during the read operation from the memory. We all know that machine cycle 1 and machine cycle 2 is concerned with the memory read, and machine cycle 3 is concerned with input output read. So Memory read bar goes low during the first two machine cycles. Wherever the read bar is low, even the memory read bar goes low. And it is high during the third machine cycle. But I/O read bar is, we know that during machine cycle 3, we are referring to the input output device, so it goes low wherever the read bar goes low during the third machine cycle. So this is it about in instruction. Now if we move on to the out instruction, it is same as in instruction. Okay, out. It is same as out in instruction. It is just replaced by in is just replaced by out. Even this requires 3 machine states, 3 machine cycles, and 10 T states. But execution process is not reading data from the input device. It is writing data into output device. Next, in order to give you a clarity, let me consider an example. Suppose that we are writing our code at 2050. Then the machine cycle 1 starts with 2050, which reads the hex code D3. So at the end of the first machine cycle, it understands that the this is an out instruction, and in the next and it is going to provide me the port address in the next machine cycle. So in the second machine cycle, it reads 01. Now at the end of the second machine cycle, it understands that yes, it has got the complete information about the instruction. Now it has to move on for execution. So during the third machine cycle, it moves to the port address and then writes the contents of the accumulator into the output device. So let's move on to the timing diagram. Everything is same, which I have told you. It is reading, in this case, it is it is reading the opcode in this case, and it is reading the 01, that is the port number in this case. And in this case, the machine cycle 3 is different from that of the in instruction. Here it moves to the port address 01, and then the accumulator contents are written into the output device. So the machine cycle 3 would be IO write. Now read bar, memory read bar are same for this instruction too. But we have a new instruction called write bar. Since machine cycle 3 deals with the write instruction, we have write bar. So this goes low. I think you all can guess it, because here the write operation is being performed at this particular place. The write instruction goes low. And IO write bar. IO write bar is this goes low whenever the write instruction is referring to the input output device. Yes, exactly. We all know that during the machine cycle 3, it is referring to the IO device. So at the same place where the write bar goes low, the IO write bar also goes low. So this is it about out instruction. Thank you for watching.